கண்டிப்பா. Good evening, everyone. Welcome to DevSync Introduction to DevOps, organized by the IEEE Computer Society chapter of Southeastern University of Sri Lanka. We are thrilled to have you all here for this insightful session on DevOps, a field that is revolutionizing the way software is developed and delivered. I am Buddhi Nanatara, the Assistant Secretary of the IEEE CS chapter at Southeastern University of Sri Lanka.
I am Nirasha Madhushani, the Chief Organizer of the IEEE CS chapter at Southeastern University of Sri Lanka. We will be your host today. Today, we will explore its core concept and real-world applications to understand why it's game-changer in modern software development. To kick off this session, I would like to invite our Secretary of the CS chapter, Ms. Heshani Rupasinha, to deliver the welcome speech. Heshani, the floor is yours.
Good evening, everyone. It's my pleasure to welcome you all to DevSync's Introduction to DevOps, organized by the IEEE Computer Society chapter of Southeastern University of Sri Lanka. I warm welcome to our speaker, Engineer Kavinda Rajapaksha, at Software Engineer at Enactor. We truly appreciate you joining us to share your valuable expertise today. I would also like to express my gratitude to our IEEE SB Counselor, Professor M.A.L.A. Halim, the Dean Faculty of Engineering, Southeastern University of Sri Lanka, and IEEE CS Chapter Advisor, Dr. W.G.C.W. Kumara, for their invaluable guidance and support. And also, I would like to welcome to all IEEE SBN CS chapter members and, of course, our audience. The DevSync series was designed to bridge the gap between theory and practical in the field of DevOps, an area that plays a key role in modern software development and delivery. Through this session, we aim to provide you with valuable insight into how DevOps support collaboration, accelerate delivery, and enhance efficiency across teams. Let's embark on this learning journey together and make the most of this opportunity. Thank you, and I wish you all a engaging session.
Thank you, Heshani, for those encouraging words. Next, we have Mr. Kavinda Rajapaksha, a skilled software engineer at Enactor. He holds a degree in computer science engineering from the University of Mortu. Please welcome Mr. Kavinda Rajapaksha as our esteemed keynote speaker today.
Sorry. I think I'm audible.
Yes.
Yeah, okay. Let me share my screen. Hope you can see my screen. To save the bandwidth, I'll switch my video. So first, thank you for inviting me to do this session. This is an introduction session to DevOps. So let's get started. So you can ask questions, unmute and ask questions. So please, I'm happy to ask questions. About me, I'm Kavinda Rajapaksha. I graduated from University of Moratuwa, Department of Computer Science and Engineering. Currently, I'm working at an actor. So I'm working in a deployment and scalability team. So we worked on a lot of DevOps up there. So I think I can share my experience with you guys. Okay, let's talk about today's agenda. Today's topic is an introductory session to DevOps. However, for the university students, discussing DevOps practices might not be very useful, since most of these practices may not be directly applied to undergraduate students while their studies and their projects. So I thought that before diving into the main topic, it would be better to discuss Docker first. Then let's move into DevOps. So what is Docker? You can raise hand, right? I think it's not good. If anyone use Docker before, can you please raise your hand? No one? I'm audible, right?
Yes, we can hear you.
Yeah. Okay. Interesting. Are there any final year or third year student here? At least second year? Can you raise hand? Please raise hand. Yeah, there are two. Yeah, okay. Okay. I'm not going to ask any questions. Just raise hand. Okay. Okay. Let's dive in. Okay. Okay. Let's briefly discuss about how Docker containerization came into picture. First, you have the computer, physical device. It's like your laptop. It runs an operating system, and all applications shares it. So think about this. You have two applications. To run the first application, you need Windows 10. To run the second application, you need Windows XP. In your laptop, can you run both applications in the same time? Uh, Maybe it's a little bit interactive. You guys can speak up.
No, sir.
Don't say sir. Yeah, no, right? Uh, so no, right? So then virtualization concept came in. Virtualization, OVM, is like having mini computer inside your computer. It runs its own operating systems. There should be some. Yeah. Here, like there are several OSs running in the same computer. I think you guys have used a VirtualBox. Maybe can you raise hand if you have used a VirtualBox? Yeah, there are plenty. So in a virtual machine, so it's run its own operating system, but it cannot directly communicate with the hardware. So VirtualBox is a hypervisor. So we need a hypervisor to connect to talk to the internal hardware. Then the problem is these are resource heavy. We need lot of CPU, lot of memory, lot of RAM to run these applications, run these VMs. So then as solution, people introduce Docker. Finally, Docker is a lightweight container. Think of it as a small package and it include all the packages required to run that application. So the interesting thing here is we don't need a hypervisor to run a Docker container. Here, each virtual machine has its own operating system. In Docker containers, it shares the same operating system, host machine actually. So next. So let's talk about the definitions. Imagine you are a developer who just finish up building new application. Maybe you have done few projects, right? It's perfectly run on your laptop. But as soon as your friend run it, something break. Sounds familiar, familiar, right? So this is where the Docker came to rescue. So what is Docker? Docker is an open source platform designed to solve this exact problem. It allows us to package an application along with its dependencies. So it solves this problem. It's work on my machine. And it's portable. It can be built anywhere. It can be built once, runs anywhere. So how we build a Docker container? Let's answer that question. First, we need a Docker image. Docker image is a blueprint actually. It read-only template that contains instruction for creating the container. So how we create a Docker image? We need a Docker file. It automates the creation of Docker images by defining the app environment in a file. So if the time permit, I'll discuss about Docker Compose as well. It's also running multiple containers in a single application using YAML configuration. So okay, let's talk about the Docker file. Docker file is a simple text file with instruction that tells Docker how to build an image. It's like a recipe for your application. In Docker file, you can define everything. What is the base image here? It's node 18 and all dependencies. We install those dependencies here. And the source code here, we copy the source code. So anyone use node before? One is that someone forget to okay two. Yeah. Shahid Mali, can you tell me why you use node? Why you didn't raise your hand?
Yeah, to run the front end React framework on it.
Okay, but to run a React application, yeah, you need Node, but you don't need the Node runtime, right? React is just a bunch of JavaScript files. So it runs on your browser. So you don't specifically need Node to run a React application. How about your backend? So what technology you use to build your backend in that project?
Spring Boot.
Yeah, okay. Let's take that example. Spring Boot is in Java to run a Java application. It's very critical to maintain the Java version. Maybe if you try to run a Java 8 application in a Java 21, it will always fail. It guaranteed to be fail. So your friend's machine need to have Java 8 installed to run that application. So now we have to resolve that problem. So how your friend run your application in his machine. So we talk about we can create a Docker image for that. So to create a Docker image, we need this Docker file. this Docker file contains of layers. Each line represents a layer. So starting from the base image, we specify the directory here and copy package JSON and run npm install, copy rest of the files, export a port, and command to run start the application. Okay, two of them told me that they have used Node before. Do you know why we copy the package JSON first and then copy the rest of the files? I mean, here it's copying the package.json file, but we copy it separately as well. Okay, seems no one answering. Okay, the reason for that is in Node, there's a large folder called Node modules. That's a super hectic folder to manage. In Docker layers, Docker engine is smart enough to know which layers have changed. So if you do a code change and build the Docker image again, you don't need to run npm install command. So that's why we first copy the package.json file, then run the npm install, copy the files. Here, once you change something, it only affects this layer. Docker do not build all these layers and build starting from this layer, it build rest of the layers. Okay, I plan to do some demos here. Let's start the first one. Can you see my browser?
Yes, sir, we can see your browser.
Yeah, okay, great. Okay, since a lot of you guys don't have used Docker, I think this gonna be an interesting demo because actually DevOps stuffs, core DevOps stuffs are much less useful for you guys, but you have to use Docker. So hope you can see my terminal as well. Okay, I copied this, I cloned this project. Now I create this project. Mm, mhm, yeah, spaces. Opening this code. Yeah. Okay. Hope you can keep clearly visible this terminal and All the files are there. So mm, okay. Another question. Just raise hand. Uh, Anyone used Copilot before? Just raise hand. Yeah, one. Okay. So I'm going to you can use ChatGPT as well. So I mean, learning a lot of things is hard, right? So you don't have to remember everything. So you have to remember the concept and use your AI to do the rest. Let's ask ChatGPT to Copilot to ask Copilot. Yeah, create this Docker file. Yeah, you will find that exact code snippet I show you in the slide. So first, let's try to run this app locally. npm install first. Okay, next npm start. Working, right? It's working on you can run it locally. So let's try to build the Docker container. Let's close this. Now it's not working. So we have the Docker file. Now we have to build that. See, those layers are there. Copy work directory, copy npm run install. This, yeah. See, this will take long time. Every time we want to do a small code change, if we try to run this one, this will take this amount of time. See? So this is the bottleneck. If you try to run this every time, it will take some time. That's why we are copying this code after the npm install. So now the image is there. So we can check that. This is on my web. So let's try to run that application. The application started. See, we can access. Okay. Now we build the Docker image. Any questions so far? Okay, seems no. Okay, we built the Docker image. Let's go forward. Okay, these are some commands I use there to build the Docker image. I use Docker build. Or list, we can list Docker images using Docker images. You can find those commands online. Another interesting thing. This one you have to answer. You all have some database installed in your machine, right? Please raise hand. I'm not asking you to speak. Just raise hand. Two, three. Only three of you. May again, Shal what is the database you are using? I mean, what are the database you have installed in your laptop?
MySQL.
Yeah. From today onwards, do not install MySQL on your laptop. There's far better way to do that. So the issue is, so you said that you use MySQL, right? There's a similar database called MariaDB. Have you heard about that?
Yeah.
Yeah. Both applications run on the 33.6 port. So if you try to install MariaDB, you won't be able to do that because that port already assigned to MySQL server. So easiest way to do that is connect running your database as MySQL containers. For I can't remember the command. Let's see here. We are trying to run a MariaDB or MySQL. Here I'm running MariaDB, same thing. Just the open source version of MySQL is MariaDB. Just assume like that. Not exactly the case. So when you running a database like this, advantage is you can easily switch on and off these containers. You can have different versions. So when you have assume you need MySQL 5 and another project need MySQL 8. You have to uninstall MySQL and you have to install it again. Without doing that, using this simple command, you can keep both Docker containers. You have to use separate port. It's a not a big issue. Then finally, you can start the container like this. Earlier, I didn't have any database. Now I have MariaDB. It's easy as like, see now demo is running. That's the application we started. And another MariaDB container is running. So use this method. This is very easy actually. So short slide. Okay. Other thing is tagging those images and pushing to the Docker Hub. So I'll discuss about that later. Okay, now coming to the main topic, what is DevOps? Okay, DevOps is not a tool, a team, or a single technology. It's a culture. So at its core, DevOps bridges the deployment and operation teams, and it helps to deliver software very fast. That's the main goal of it, and more reliably, while maintaining the high quality. On this screen, you can see the Infinity logo. This is the logo which symbolizes DevOps. So it's a continuous loop of activities like planning, building, testing, monitoring, and like us. This loop shows the DevOps is an ongoing process. So why DevOps matter? In current world, speed is everything. With DevOps practices like continuous integration and continuous delivery, teams can release update faster than ever. So, and improve product quality by incorporating practices like automated testing and continuous monitoring. DevOps help teams to catch bugs uh, in earlier stages. The result is always a high quality product that not only meet the requirement, uh, also exceed the customer expectations as well. So let's talk about technical benefits. Automation is key part of DevOps. Tasks like running tests, building code, deploying updates, we can be automated those things. As I told you before, it's reduce the time. So let's talk about the core DevOps practices. We have talked about what DevOps is and why it matters. Now let's look at the key practices that make DevOps successful. These practices help teams deliver high quality software quickly and reliably. So first thing is continuous integration, uh, in short form CI. This ensures every code changes automatically integrated, built, and tested. We can use tools like Jenkins or GitHub Action to automate this. This provide quick feedback to catch bugs. I mentioned that previously as well. So next thing is continuous delivery. It ensures that code is always ready for deployment. So for that, we can use blue green deployments. There are so many deployment strategies that we can use for this. And infrastructure as code that I'll be discussing in detail in later chapters. And monitoring and observability. Once your application is running, how do you ensure that it's performing well? That's where the monitoring and observability matter. Uh, Tools like Prometheus, Grafana, ELK stack, we can use to use those tools for monitoring. Yeah, these are some example for CI/CD pipelines. In industry standard is Jenkins. So using Jenkins, we can run very complex pipelines. GitHub Action is much simpler one. So even you can try out. Let's do a demo for that as well. Just for running test and may want to do Java builds and so this is a Jenkins script. We use a language called Groovy for that. It's a superset of Java, I guess. And this is how the dashboard look like. GitHub Action. It's a simpler form of pipelines. We define the pipeline in YAML format, and in our GitHub we can look. It's look like this. So let's do another demo. Okay, now we have our Docker images. So next thing is so now we have the Docker images. Let's go to the GitHub. Here you can find the GitHub actions. This is a pipeline. It's free to use. I think they give 800 hours per month or something like that. Basically, it's free. Free for, I mean, small purposes. So now we have the Docker images. And another thing I forgot to show you here. This application has some test. We can run those tests here. Okay, something went wrong. Okay, application is running. give you this one. If for some reason it is not working, let me switch back to my other workspace. So it's the same workspace. Using this command, we can run the test. So let's build a pipeline to let's create a pipeline to run this test. I already created that pipeline. Here you have to in your project you have to create a folder called .github/workflows. Those are two directories, and here in this YAML file you can define your pipeline. Here what I did was, when creating a PR, I think you know about PRs, right? Pull requests. Just pick hands up. Are you guys using GitHub? Again, Shalita, how you keep your source code in your project?
Bagaimana entender?
Can you just raise hand if you have used GitHub before? I mean, if you don't know GitHub, there's no point of doing DevOps, introduction to DevOps. One person, two. At least three. So is it okay to ask a question from you or the people who raise hand? Okay. Yeah. Kavindu, I also. Are you guys serious? Uh, anyway, as a IT grad, undergrad, you should know how to use Git, and you should know what is pull request. It's yeah, there are yeah. What I did was when someone create a pull request against the master branch, we run this job. It in pipeline there are steps. We can define step. In each step, let's discuss each step. First, check out the code. Check out the source code. Then setting up a node environment and install those dependencies and run test. So I did not able to scroll to the okay. Once you create that pipeline, when you create a pull request here, if you don't know, here's where we can create pull request. Once you create a new pull request, it triggers that job. So I have created, sorry. So I have created two pull requests. In one, what I did was just updated some random name. So it should not affect any test cases. So if you go to the pipeline here, if you go to that pipeline here, so all tests are passed. So that's the success case. So in the second pull request, what I did was I go to some test and it's waiting for false. I set it to true. Now at least one test case should fail, right? So if you go to that pipeline, here, this one fails. If you go inside that pipeline, you can see the exact, yeah. So without this pipeline, someone can merge this code changes into a master branch. That will cause to this in this case I only changed a test case. It will not affect the code base, but some code changes can affect the system badly. So that's why that's why pipelines are so important. Okay. Next. So this is a production architecture. There are so many resources. So how do you think DevOps engineers manage this infrastructure? Obviously, we can go to the AWS console and create these resources, which is the fastest way, however. But in long run, when we need to manage this infrastructure effectively, we require more robust way. So that's where the infrastructure as code comes in. Infrastructure as code, in short form, IAC. It's all about managing and setting up infrastructure using code. Just like we do for the application development, instead of manually setting something, we write codes to define servers, networks, and other resources. The beneficials are huge. First, with version control, you can track every changes to your infrastructure and roll it back if not necessary. And also we can scale things really fast. And finally, popular tools will be Terraform to declare multi-cloud infrastructure, Ansible to configuration management, and CloudFormation to manage AWS native cloud resources. Okay. This is two infrastructure support tools. Can you tell me this language? This is very similar language, I guess. It seems someone knows this language. This is actually Python. So the Terraform syntax is unique. Because of that, people are not like to learn that. So to resolve that issue, AWS introduced AWS CDK. It uses Python. Using Python, you can define any cloud resources, but this is limited to AWS. Okay, next slide. So what is Ansible? Ansible is a configuration management software. So earlier we discussed about infrastructure. So if you need a EC2, you can't do it using Ansible. You need to use Terraform or AWS CDK, CloudFormation, something like that. So once we have the infrastructure, let's say we create a VM using Terraform, and then you need to install Docker there. Now we create a Docker image. Ultimate goal is to deploy that Docker image in a EC2, in a VM or somewhere. So if you launch a EC2 instance, by default, they don't provide Docker. So you have to install that. So you can install Docker in one machine. That's not a big deal. How about you have to manage hundreds of servers? That's very painful. You have to go each servers and run bunch of commands there. To resolve that issue, we can use Ansible. Ansible is powerful because it's agentless, because you don't need any software to run Ansible. It's only require Python to run that. This is a simple script. This script used to install Docker. It's a configuration management tool application. You can do application deployment, orchestration of complex tasks. Common use cases would be provisioning servers with consistent configuration, automating repetitive tasks like software updates, that I talked before, orchestrating multi-tier application deployment. I planned a demo for this, but since you guys do not have proper basic understanding. I don't think typing bunch of Terraform code makes sense to you. So anyway, I'll discuss this briefly. I don't go into the demo right now. So let me put it as this way. So you have heard about AWS, right? Raise hand, please. Yeah, two. Yeah, okay. So uh, instead of doing the demo, I'll teach you some basic of AWS. I think that's more important here. So in AWS, it's like AWS provides you some EC2s. EC2s means VMs. That's the AWS name for that. So, but it's a very large infrastructure. So anyone can create VMs there. So how they limit access to that VM? So that's security risk, right? You create a EC2, someone else create a EC2. There is a network path in between that. So how to isolate resources? To do that, we use VPC. It's VPC mean virtual private cloud. Inside the VPC, you can create resources. So now outsiders cannot go inside these EC2s. So in inside VPC, you can have multiple subnets. Here we have two subnets, public subnet and private subnet. Public subnet mean that name also have the meaning of it, can access to the internet. Here's where the internet facing elements are there. Basically, to connect to this EC2 instance through internet, you can using this internet gateway. Internet gateway is like think as Mobitel or dial-up, some telecommunication provider. So using this internet gateway, we can access this EC2 instance. But when it comes to private subnet, it does not have any access to the outside. So, but those users need to go to internet. To do that, we have this NAT gateway. So what I plan in this demo was, so I need to deploy this application inside a container, inside a EC2. So to deploy that, so I talk about and let me go to the AWS console before coming. Okay. This is the AWS console. So here you can create those resources. Not this one. Yeah. So if you go to that VPC, inside VPCs, you can create VPCs. This is some process, right? I think you understand. Someone goes and manually create those VPCs, that person can make mistakes because human make mistake. So to avoid that, we instead of provisioning them manually, we write a code. So hope you remember this architecture. Here we create that VPC and we create this internet gateway and that subnet. I didn't create the private subnet, and to connect the internet gateway we need a right router and the router association. So here those infrastructure is written as infrastructure written as this code. So next you need some EC2s. So to access EC2, this might not be useful for you. We need a key pair. We need to generate that key pair. We need to enable some security groups, and then here we create that actual EC2 instance. So like that, we build the entire infrastructure here. Then what we can do is we type Terraform plan configuration file. How many more? Okay. Terraform, what Terraform does here is it says no changes. I recently deployed that. So here in that TF state file, it has the state of our infrastructure. So we compare, not we, Terraform compare the state with the actual AWS. So it calls all AWS APIs and check whether there is any difference. So if there is any difference, it will apply that changes into that. Let me do a small change here. I can change here. Maybe add another English rule. Let's allow HTTPS. So I can do the same thing. Go to the AWS console, go to EC2. Security. Security group. Here that two security group we define here, port 80 and port 22 is there. So we can edit this one and add that security rule. This is a lot of work, right? Here it's only we need to change at this line of codes here. So let's see. Let's go. Terraform and change. Want to change? Now we can apply those things. Look, remember we didn't add that here. Let's cancel that. Still tools. It's done. Yeah, now it's there. So when it comes to large infrastructures, manual editing things are really hard and really cumbersome. That's why we use Terraform. So this is really easy, right? So that's it. Another interesting thing, I did a little bit experiment with Copilot. I didn't write any single code here. So you don't need to learn. I mean, you have to learn the core concepts, and writing the code will do the ChatGPT or Copilot. So now the EC2 is there. You go to the EC2 instance, you already saw that this is there. Now, but this is the Ubuntu image. Now we need to install Docker there. To do that, we can do it using Ansible script. So here in Ansible there are modules. This APT is a module. So APT key is another module. So okay. This is simply, instead of running few commands, we define that command in a YAML format. So install those repositories, adding a key, add repository, again installing Docker, enable Docker, add user, some configuration. I didn't write this code. I don't know what's happening here. So now we're using that Ansible command, Ansible playbook. I hear the not interesting thing. It's you have to define your host here. This is a public IP of that easy to use, and it uses this key to connect. This is a long key. Maybe you can learn this stuff if you are interested in security. Using this command, you can install Docker in a VM. So since I already run this command, I think nothing will happen. Right. Okay. Okay. We discussed about a lot of core practices, but we missed something. Those are container orchestration. For the container orchestration, we can use Kubernetes or Docker. I haven't used any other services, but those are there. And monitoring. I discussed briefly about monitoring in earlier slide, but I didn't go deeper into those services. You can use Prometheus, Grafana, Datadog, and in our company we use Zabbix. Yeah, that's all. Do you have any questions? You can ask anything.
Yeah, how does the software testing part changes with the introduction of DevOps, like the traditional methods versus the new methods?
Yeah, traditionally, there are QA persons. Still, there are a lot of QAs in any software company. They have to manually test those features. So what happened is earlier they used before Agile. I think you already know about Agile and waterfall development strategies, right? In waterfall, once the planned work is done, QA started to test those features, newly added features and existing features. That will take a lot of time. So now what we do is still we have QAs, but most of the test cases are automated. So we can use Selenium, or at core level we use unit tests. We can use JUnit, or I saw you in that jest for the node. So using such tools, we can automate the testing process. So likewise, because of DevOps, uh, that part is continuous integration. Because of continuous integration, companies save a lot of time and money. So one question: how many first years are there? Just raise hand. No. Yeah, any more questions? So
Excuse me,
yeah, go ahead.
I have a project I'm doing in image processing.
Okay.
Now my laptop is required to run this program because computational powers. So I'm running in another computer. So using Docker, can I run in my laptop?
So
Because
what's your problem is you don't have enough resources in your laptop. You are using another one.
Yeah. Yes.
So it's not a Docker problem. You need remote SSH. So using Docker, you can't solve that problem. So what you can do is, I mean, when running image processing and stuff, main problem is processing power. When running that application, even GUI is very headache, because that's also wastes a lot of resources. What you can do is install the minimalistic OS, like Ubuntu. I prefer Ubuntu server and SSH into that using your laptop. That way you can boost your performance. In that way, in that case, only application running inside your server, your other laptop, is that the image processing task. No UI task running. So that way you can increase your performance, I guess. Does that answer your question?
Yes, right. So another question is, if I want to run my program in a server, what will happen then? How I do that?
Sorry, come again.
If I want to run in the network, like this image processing task for the identifying object. So there we are connecting it to the network. So network need to run it. But my problem is doesn't have that powerful to run the network inside the network. So how I manage that? Can I use Docker or something like that to run in the network, the server?
I'm not still getting your question. So you have some heavy task to run. So
Yes.
what is the relation with the network?
It's running in the main computer, but program need to run in the edge computer. That's the problem.
So you are processing it at edge. Is that so?
Processing it in the main computer. It's
Okay.
but my camera and other things setups in the another computer, another edge computer.
Yeah. So you have bandwidth issue, right? Is that the problem? Processing or the bandwidth?
I don't know what problem is because I'm just researching through how to do this right these days.
Okay. I'm not sure about that. If you are running edge task, if you are doing edge computing, you can definitely use Docker, but there's a problem in Docker. The problem is it does not, in the technical terms, it does not have the pseudo randomness. So it the minimalistic version of some Linux container. So that doesn't have enough power like VM or a computer. So I think you can't, for your problem, you can't use Docker.
Thank you. Ajay.
Any questions? We have 4 minutes left. I think we can wrap up.
Thank you, Mr. Kavindra Rajapaksha, for your inspiring and insightful keynote address today. It's time to express our gratitude for Mr. Kavindra Rajapaksha's significant contribution. We would like to present you with a token of appreciation as a symbol of our gratitude. Could you please accept this token?
Thank you, Mr. Kavindra Rajapaksha. We are so grateful for your support. To conclude our session, I would like to invite Mr. Lahira Vijayakon, the program lead of the IEEE Computer Society of Southeastern University of Sri Lanka, to deliver the vote of thanks. Mr. Vijayakon, over to you.
Good evening, everyone. On behalf of the organizing committee, I would like to express our thank you to all of you for joining us today. First and foremost, we would like to thank our speaker, Engineer Kavinda Rajapaksa, Chief Software Engineer at Inac, for taking time to share his valuable insights today with us. Yes, a special thanks to Professor M.L. Hari, the Council of our IEEE branch, and Dean, Faculty of Engineering, Southeastern University of Sri Lanka, and Dr. W.C.W. Kumar, the advisor of IEEE CS chapter, for giving this opportunity to us. Finally, I would like to thank our organizing committee and every one of you for your time and attention. Your presence here today has made this great. Thank you all once again, and we look forward to your continued support and participation of this event. Have a great rest of your day.
Thank you, Mr. Vijayakon, for your heartfelt vote of thanks. Before we officially end today's session, let's take a moment to capture this historic event. I would like to request all participants to kindly turn on their cameras so we can take a group screenshot. Let's all smile and make this moment memorable.
Okay, I will count down. 3, 2, 1. Thank you all.
Thank you, everyone. This brings us to the end of our session of the IEEE Computer Society chapter, Southeastern University of Sri Lanka. We appreciate your presence and participation. Have a great day ahead.